Hi everyone, my name is Jan, and today I'm gonna talk to you about the research focused on examining the impact of rumble strip installations in prevention of lane departure crashes in Maine. So, with the introduction, we can say that the data was obtained from the Maine DOT public map viewer online resource, as well as from representatives of Maine DOT, and analyzing the crashes in Maine from 10 years, from 2010 to 2022, well, we can see that the percentage of lane departure crashes are around 30%. However, this is only the crash frequency, but when we look at the fatalities due by the crashes, then the lane departure crashes account for at least for around 70% of those fatalities. So, as a measure to prevent the lane departure crashes, Maine DOT has installed rumble strips in its roadways. So mainly in major collectors, minor arterial, and other principal arterials. Also in interstates, but interstates are outside of the scope of this research. So we are focusing on major collector, minor arterial, and other principal arterial. So we can see along the years, major collectors has the lowest of fewer installations. And then minor arterial between 2015 and 2018 has like fairly installation of standard and sinusoidal rumble strips. Again, in 2020 and 2021, it has installations of sinusoidal rumble strips. And other principal arterials has a considerable installation of standard rumble strips in 2016 and a considerable installation of sinusoidal in 2021. So then if we go to the methodology, we are gonna use before-after studies using three different methods: comparison group, empirical base, and empirical base with comparison group to assess the effectiveness on the rumble strips. So this before-after studies focuses on comparing what will be the crash frequency of the crashes if no countermeasure will be installed against what is the crash frequency of the crashes given that the countermeasure was installed. And for that, we need data from a period before the installation of the countermeasure, in this case rumble strips, and data from a period after the installation of the rumble strips. So we need to select the elements, and the selection criteria was geometric and traffic characteristics. So the road elements and crashes were aggregated by each unique roadway segment identifier, ADT, and speed limit to have longer segments. Again, also for this method, for the empirical base and the empirical base with comparison group methods, was necessary to develop safety performance functions using a negative binomial model to predict the number of crashes if the countermeasure will not have been installed. And then crash modification factors, or CMS, were computed for different facilities and types of rumble strips. So the results, well, there was data limitations because on 2020 there were the stay-at-home restrictions because of the COVID-19. So this induced a change in the traffic characteristics and behavior of the drivers in the time posterior, during and posterior the restrictions, and that it was difficult to capture in the models. So for the methods, it was not possible to use data that it was from 2020 or beyond that. So that restricted our available data or installation dates of rumble strip. So for example, if we go back to this figure, well, installations of 2020, 2021, we cannot use those ones. Also, because if we need 3 years before 2021, the crash data is only until 2022, right? So given that restrictions, and after trying 3 methods, the comparison group method was the method that gave us more results with the statistical significance, and those are the ones presented here. So we can see that for minor arterials, standard rumble strips installed in evaluated with the installations of 2017 gave us a crash modification factor of 0.53, and is statistically significant. For other principal arterials, we got CMS for a standard and the combination of a standard and sinusoidal rumble strips, and then also for the combination of arterials, we got CMA for standard and the combination of a standard and sinusoidal rumble strips. And this is regarding of the total crash frequency. And we also did the analysis for the fatal and injury crash frequency. And we found for minor arterials, a CMN and CMF for the combination of standard and sinusoidal rumble strips, evaluating the installation of the rumble strips in 2016. For other principal arterials, we got CMFs for the standard rumble strips, and then for the aggregation of arterials, CMF for standard rumble strips, and for the combination of standard and sinusoidal rumble strips were found with statistical significance. And well, after knowing the CMF or how the rumble strips affect the crash frequency, it was possible to compute a benefit cost ratio analysis, and then to evaluate if it is worth it or not, the installation of the rumble strips. So the crash costs they were estimated using the cost per level of injury of each crash, and then those costs were aggregated to obtain the total crash cost, and then it was divided by the number of miles and the number of years that were considered in the analysis. After obtaining the total crash cost, the benefit was computed using the CMF. So we compute what are the savings of the cost of crashes if the rumble strips are installed. And then for the installation cost, it was assumed that the service life of the rumble strips 7 years, being in the conservative side, and then with a cost of $3,500. So the cost is $500, and after doing the benefit cost ratio, we found that the rumble strips are cost-effective countermeasures to prevent lane departure crashes. So this is all for to present it today. Thank you very much for your attention.